Alright, so we're going to do the first section of Unit 6. And as you see, Unit 6 is about limits and polynomials. Let me zoom it in a little bit so that we can see a little better. It's about limits and polynomials, but before we actually start talking about polynomials, we'll talk about what is the limits of a particular function. What is the limit of a particular function? So basically, normally when you have a function, you have a graph, and limit allows you to see how the graph is behaving at a particular point. And obviously this will, I think, get clearer as we explain it with the graph, but let's just write this down. Many mathematical problems involve the behavior of a function at a particular value. Limit is the behavior of the function around that particular value rather than at. So the key word is around. How is it behaving at x equals, not at x equals to c, but how is it behaving around x equals to c? Okay, what does that mean by that? Let's just look at this. So if you read this graph, what is the value of f of x as the graph approaches one from left and one from right? So what do we see here? So basically, what is the value of f of x? So basically I'm trying to read, always keep in mind, you're trying to read y given some x value, but here as x is approaching a particular value, approaches 1 from left. Okay, so this is x equals to 1 and you're approaching 1 from left. That means you're approaching from left side. Where is my y value? My y value is actually here. And what is the value of y as you're approaching it from the left side? It is 1, 2, 3, 4. So it's negative 4. But the same value when x equals to 1, but when you're approaching it from the right side, what do we notice? That it stops at x equals to 2. So you get two different values depending on whether you're approaching it from the left or right. And this is what is called as the limit at x equals to 1. So basically how they'll ask you is what is the limit of f of x as x approaches, as we are approaching x equals to 1. Okay. So here we notice that one more thing. Okay, so we have one-sided limit and two-sided limit. But if you look at this value, what's this? 1, 2, 3, 4. 1, 2, 3, 4. So when x equals to negative 4, this is your y value, right? This is your y value, which is 1, 2, 3, 4, 5. Negative 5. This is negative 5 at y equals to negative 5. So at x equals to negative 4, when you're approaching it from the right hand side or left hand side, you get the same value of negative 5. And when you're approaching it from both the sides, you get the same value. That is called as a one-sided limit. So to indicate limit approaching a value from the right, we use the following. As x is approaching a from the positive side, and to indicate a is approaching from the negative side. Okay, so what this basically means is for you to say approaches x from the left, so you're basically going to say as x is approaching 1, but when you're saying from the left is lower value, minus 1. And this one will be as x is approaching 1 from the positive side. And that's why this positive and negative after the number as a superscript. So 1 minus and 1 plus. So this is also a plus and a minus. So it is a one-sided limit. When you're approaching from both the sides, from the left side and right side, you get the same value. So if you were asked what is the limit of f of x as x is approaching, what was this? X is approaching negative 4 from the left side, you would say it is negative 5. From the right side, you would still say negative 5 because it's both approaching to the same side. Whereas if you had talked about this one, right, which is what we saw, this is basically as x is approaching negative 4, and here as x is approaching positive 1. When your x is approaching positive 1, what do we notice? We notice that the limit is got two different values. From the positive side and from the negative side. So from the positive side it is 2, from the negative side it's negative 4, so that's called as a two-sided limit. If a function has the same one-sided limit to the left and right, then the limit exists at that point. So two-sided, so this is basically a two-sided limit. And this is basically one-sided limit because you're approaching the same value from both the sides. Okay. Now I'm not going to do this anything more than this, just because it's I want to show it to you with some values and to show you what basically we mean by the limit. Okay. So here it says, so for now we'll leave the graph alone and we're going to read a table. Use your table feature and we can use the calculator, but let's just give it, let's see what we're talking about here. Find the limit of this function. So this is my function. Find the limit of this function as x is approaching positive 3, but from the positive side. So on the graph, what will mean? 3 is here, so you're approaching it from this side. You're approaching the graph from this side. What is the value of y? So when you're approaching it from this side, you're getting closer and closer to 3. So what do you notice here? How do you notice your x value? X value is just slightly above 3.1, but you want to get closer and closer to 3. As you get closer and closer to 3, what is the value you're going to see? So I want you to use your calculator and substitute. For the first one, you'll say 3 minus 1 minus 3 plus 1. When you put this in your calculator, what do you get? Square root of 3 minus 1 minus 3, which is 0.1. Square root of that plus 1, you will get 1.3. I'm just looking at my calculator and seeing what I'm getting. Then I do 3.01 minus 3, right? 3.01 minus 3 plus 1. What do I get? I get 1.1. And I do the same thing for these two. I get 1.03 and then I get 1.01. What do you notice here? As you're approaching 3, getting closer and closer to 3, what is happening to my y? Y is getting closer and closer to what? This is what we mean by limit. As you get closer and closer to a particular x value from a particular direction, that's why you need that positive or negative. So you're getting closer and closer to 3, but from a higher value. That's why you start with 3.1, go to 3.001. What happens here? Okay, let's look at one more thing. Let's look at one more before we look at something else. What is the limit of x minus 2 over x as x is approaching 0? So let's write this a little bigger, from the positive side. So you notice what happens here, right? When you substitute for x equals to 0, what is the value? Yeah, right here it's asking you. When you substitute, see, you're not calculating the value of this function at x equals to 0, but because when you put x equals to 0, what do you notice? 0 in the denominator is going to be does not exist. It's undefined. It is undefined. Same thing for this. When x equals to 3, 3 minus 3 is 0, square root of 0. So that's not what we're looking at, right? We're looking at it as it's approaching 0. So what are you going to do? And you're approaching 0 from which side? So let's draw a graph here. So this is 0. It says 0 plus, so you're approaching it from here. So what is slightly above 0? 0.1. But you want to get closer and closer to 0. 0.01, 0.0001, 0.0001. And what is the value of f of x? So it's going to be, so I put this in my calculator. What do I put in my calculator? I put in my calculator 0.1 minus 2 over 0.1. Put that in your calculator and what do you notice? Put this in your calculator, 0.01 minus 2 divided by 0.01. So you're going to do 0.01 minus 2 divided by 0.01. And I get negative 199. I put this in my calculator, I get negative 1,999. What do you notice here? It's really not getting close to any particular number. It's really, so it does not exist. So it's basically getting close to negative infinity. Because you see it's getting smaller and smaller and smaller, so it's actually approaching negative infinity. It's approaching negative infinity. So I hope you're sort of getting some kind of a clarity as to what we mean by limit. So just think about it conceptually, that limit is nothing but given a function, you are asked when x is approaching a particular value, when x is approaching 3 or 4 or whatever, what is happening to my y? You are not calculating the value of function at x equals to 3, but you are basically going slightly above 3 or slightly below 3, depending on whether you're coming from the left hand side or the right hand side. So this is as far as tables are concerned. We will also look at the graph. Graph is what is actually really useful, but before that we'll look at direct substitution. In this case, we didn't do direct substitution, but here we'll look at the direct substitution. So here it says limit of x minus 5. Okay, let's fill this in. Solve a limit by direct substitution. And let x equals to c. Okay, to find using direct substitution. So just write it down, and we'll talk about this. So this is limit of x minus 5 as, this is really small, so I'm going to write this down, as x approaching 1 on the positive side. So in this case, I'll go ahead and do direct substitution. Direct substitution will be 1 minus 5 equals, you're basically evaluating it. So when they tell you direct substitution, you're just going to be evaluating it. Limit of this as x is approaching 1 from the negative side. It doesn't matter whether you're talking about from the negative side or the positive side. The value of x you're going to substitute is still 1. So it's going to be 3, 1 cubed plus 4 times 1. And what do you get? This is 3, this is 4, and you get 7. Alright, so this is just direct. So if they ask you direct substitution, you're just going to substitute it. Okay, let's keep going. Let's look at one more for direct substitution, and then we'll look at the graph. Graph is when the limits actually start making sense, because you'll see that. Limit of sine of x as x approaches pi by 4 from the positive side, but you're doing direct substitution. So what is sine of pi by 4? Which is square root of 2 over 2. Direct substitution, correct? We just did this in trig, so it is square root of 2 over 2. Okay. We will start with the graph, but we will pick that up in the next video.